Okay, for people joining this live stream, we are watching Leonid's screen here, I think, and we will be talking about aspects of the future of arrays in Wolfram language. And we have several different projects running right now, and maybe we'll hear about some of them here because I think it's been a while since we've had a meeting. We have the data container project, and we have this data set backing with other things project. So maybe Leonid, maybe you can uh, define what this is. So this is backing data sets with databases. Is that correct?
Yeah, although potentially it's a wider approach than just databases. The essential idea is that you can back a data set, but by various different backends. They can be flat data or relational or maybe hierarchical data as MongoDB. And the idea is that we try to generate the queries which from dataset queries, we try to generate queries in the target language that would allow you or the users to essentially use dataset query language, but behind the scenes to
Okay, so Leonid, this was the original idea of dataset. Back when it was originally conceived, this was the idea about how it would work. So this is good. I strongly believe in this idea.
Yeah, I think there are very good indications that this is a very fruitful direction. And I have to say in advance that it is not orthogonal, it is not exclusive, mutually exclusive with data container. And I think that's a very important point to take
I
home.
agree. You're right. I mean, data container is, well, I mean, data container is a more lightweight thing, but data container will presumably be one of the implementation methods relevant to certain kinds of data sets. Like if what's in a data set doesn't have any of the kind of wrapping that data container makes useful, like being able to put in units and things like this, then you don't need data container here. Or doesn't that, I mean, as I understand it, the thing with data container is that it is a translation layer that allows you to both wrap the contents, deal with missings, and potentially have a formatting of the underlying data that is not, you can access it using standard part specifications or whatever, but it may be stored in some different way. Is that right, Rob? Can you speak to that? I mean,
that's basically right, and it's more lightweight in the sense that it's intended for much more rectangular data than what the Leonid is trying to work with.
Although, let's be realistic. I mean, most of this data is going to wind up being rectangular. So while we need to be able to deal with the special case of it not being rectangular, or not really special case, the general case of it not being rectangular, if we can optimize the rectangular case, we're already at the 95% level.
Yeah, then that's what the data container is kind of intended to do, is to optimize that case.
Mm-hmm. Yeah, so returning to this approach that I'm pursuing, the idea is that the target language can potentially be anything that is behind the particular backing of a data set. So it's not necessarily even a query language in the usual sense, like SQL or like MongoDB query language. It can be an API, like a set of function calls. Like for example, if the same data container framework exposes certain primitives like selection or like group by or certain other primitives in its own way, or maybe it proxies to arrow backing and exposes arrow primitives, then the possible target language could be a set of those function calls. And therefore, this approach should allow people to still use dataset query language without actually knowing.
We get it. We get it.
Yeah.
We understand. Okay. So all a very good idea. launch. Let's see what you've got.
Okay, so I originally started with the simple flat in-memory data. That was like the first phase of my work, was to have a proof of concept with the flat data which simply lives in memory.
By flat, you mean that what was rectangular has been flattened out like a Fortran array or something, or what?
Yeah, basically I can quickly show on an example what I mean. So there was this sample example I was using, which is the planets data set, which is almost the same as from the documentation of data set. And then jumping to the flat data, it looks roughly like this. Each row contains, so it's basically a list of associations, each of which has a number of unique keys which have some correspondence to the hierarchical keys of the original data set. So for example, here you can see that there are two keys with the name mass, but they have different prefixes or different numerical indices. And one of them corresponds to the mass of the moon, while the other one corresponds to the mass of the planet.
Yeah, right.
So the mass of the planet and the mass of the moon obviously are at different levels of the data set in terms of nesting. However, when
I get it. I get it. You can flatten it all out. I mean, I personally, I would have done the flattening differently, because I would have just had the name of the key just be the hierarchical series of keys that you would need to drill down to that element.
Actually, this is how it's done. This is how it's done internally, but there are some reasons to prefer, purely technical reasons to prefer string keys at the end. So in fact, I don't know if I'm able to show it here. Maybe not, because, okay, this is a previous version, but the basic idea was that the bridge between the two representation is this object that I call tabular dataset schema, which in some sense is a generalization of the data dimensions notion from the data container. Although I came to this from completely independent needs, just to bridge these things, but conceptually you can think of this as a generalization of that. So what this is a metadata which basically tells you what is the type structure.
I get it. It tells you how to reconstruct it. I mean, this looks incredibly similar to what I imagine data container will do.
Yeah, and because it's nested, you can expand things and you can see the inner structure.
Okay, question. With data container, are we also imagining that we will have a nesting denesting possibility for data container?
That's probably for Rob, but I have a few ideas about that. But let the Rob.
Yes, so that's a lot of what I've already written. Is the so you have nested associations, and it denests or flattens and comes back. And
okay,
and
so how similar is what you've done to what Leonid is showing us here?
It's a little bit orthogonal. Mine is very much set at a rectangular scheme. So I'm not creating new keys or something, because I'm assuming stuff is rectangular.
No,
so
wait. That was the question I was asking. What I'm asking is, you are not nesting and denesting in this way. So Leonid has something here. Okay, so that is clearly technology that's useful, but technology you can immediately use, Rob. I mean, one aspect of data container could be, this thing is really supposed to be hierarchical, but it is going to be manipulated as non-hierarchical because that's our efficient back end.
Well, but I think the point is that with any of these things, there needs to be sort of right. I mean, there's sort of this, what is the space of schemas that you're allowing, right? And in the case of data container, it's allowing schemas that are rectangular-ish. This is allowing a different set of schemas, right? So this nesting stuff is a whole other class of schemas that requires a whole other interface for dealing with.
Yes, but then look, there's two things. There's the front end schema and there's the back end schema. The front end schema is what is the surface level thing that will be the result of normal, basically. And the back end thing is into what is this being turned for final manipulation?
Stephen, maybe a few things will become more maybe more clear or more packed with more information once I discuss a little bit about the relational backing for this idea.
I see the idea here. This looks good.
Yeah, so this is what you were talking about.
Yeah.
That there is a direct translation between the keys and the what you suggested as essentially a set of
I don't understand
levels.
why moons is missing from the key designation there.
Why moon is what? Sorry?
Missing from the _mass_9. Why is that on the key on the left? Why are you not including everything you need to resolve where that key lives in the whole structure?
Well, because I think it's in this particular case, it's a matter of style. But for relational backing, for example, the keys that are in the database, they are string names anyway. So you will anyway need some way to translate some mapping. So here, I simply maintain that mapping within the schema and separate from.
But that's incredibly similar to what's happening in data container. You're maintaining an outer schema. I mean, there's the outer schema that you're maintaining, and then you've got an inner schema that is that raw schema there that's the _mass_9. And that must be so. Let's please get some consistency in how we do this and what the names of the keys are and stuff like this. Does that make sense?
Yeah.
Yes, but I mean,
I guess the question, Leonid, is there any reason you couldn't name that key mass_9 something like, moons _ a sock element or some underscore mass?
Yeah, I guess there is no deep reason for not doing that.
Right. I mean, maybe there's a string length limit or something. I mean, but that's sort of how the compiler does demangling, is it sort of puts the types together with underscore, and it's much easier to tell what you're dealing with when you look at some internal function than if we just created numbers there.
Let me explain one reason why it's not a good idea in my view. The thing is that when you run the queries, you end up with the data sets which have different structure, because certain levels collapse, certain levels get, they disappear, new levels appear. And so if I tie these names to the original nested structure of the original data set, then I'll have to bother to rename them every time when I do the data transformation. While what I prefer to do is that what changes is the metadata and the mapping, but the underlying column names remain the same as they were originally.
Okay, but look, Rob must have the same issue. That is, if he extracts a row from, or a column, let's say, from one of his tabular, rectangular objects, that column, let's say it's an association of associations. That column, do you rename the thing based on the underlying, on the second level associations keys, or do you keep both levels of keys?
Well, okay, it's for you.
No,
sure.
Go ahead, Leonid.
No, there was Rob, it was a question for you, I guess, right? Stephen?
Yeah. So the way, and again, since I started working the tabular stuff, I haven't done that much, deep thought into or actually any real work on it because I've been doing other things. But I think the thing too. So if you say eliminate a level and doing a part, we'll kind of, we remap the schema, the rectangular, and basically change the name of how that appears. Though that would still, so if we have, say, a name dimension level, which is, say, mass, okay, that's going to stay as mass as a name dimension level.
Yeah, but you see, I maybe...
Sorry, Leonid, one question maybe, because before we spend too much time into this topic. Are these keys actually visible, or they're just meant to be used internally for indexing?
No, these keys are only the keys which you see as string keys. They are only visible. They are not visible for the end user at all.
Okay.
All right, fine. Okay, I see the argument for Leonid to have this, this level only type key, and I think it's reasonably convincing. So I'm okay with that.
Yeah, I was going to show some examples to convince you about this, but I guess we can probably move on. If
I'm convinced. At least I'm convinced. I don't know.
Yeah.
By the way, what is vector? Is vector list?
Yes, vector is a list. Essentially, it's just the.
Why are you calling it vector?
Because the data set has a type system, and the type system of data set has essentially 4 major containers, which are a sock, vector, tuple, and struct. And so these names, they follow the conventions of the dataset type system.
Okay, but so wait a second. That dataset type system has never been exposed to anybody.
Right. So the distinction, I haven't seen this, but the same distinction exists in the compiler as well. And I can guess from the names what it is. I mean, basically, there are 2 types of lists. There are lists where, it's a sort of variable length thing. I have a million records, and here they are. Then there's lists where it's like, this is the X and this is the Y, or this is the latitude and this is the longitude, where it's a fixed length thing.
Exactly.
Right. So tuples are the second, vector is the first, and it's the same distinction between assoc and struct, presumably.
Yeah. In fact, I have a slide where basically there is this. You see, there is this small table.
Yep. That's exactly what we just said. Right.
Yeah. That's exactly what Christopher said. And so, yes, you're right, Stephen, that explicitly this type system has not been exposed to the user in the sense it was not documented. But if you look at every input format, any data set, it contains the type expressed with this type.
But we need to not make the mistake of saying just because it's been there internally, this is what we're going to now expose. I mean, I understand the functionality is fine. I don't think the names are right. And I think, we just have to be a little bit careful.
Yeah. So we'll have to. Yeah, go ahead.
Well, sorry, I was going to ask a quick question. So do you know? I assume that the schema that the dataset type system, figures out. I assume that's also what's used to make the sort of output form for dataset, like the visualization.
Absolutely.
And so if the output form, I mean, most of the time, like maybe 90 to 95% of the time, the output form of the dataset is correct and there isn't any kind of weird glitchiness to it. Does that sort of mean that that's the fraction of the time the type system pretty much figures it out?
Yes.
Yes.
Okay. In fact, there are 2 ways. One way is direct, which is it's called basically not inferencing but deducing the type. So you take the data as it stands and you deduce the type. And then the second one is through this type inferencing rules. And the 90% something percent of cases, type inferencing just works. And then you don't have to re-measure the data, essentially, rededuce the type.
Okay, this from the wild data type deduction is what semantic import was supposed to do.
Well, maybe. I know that currently it still lives in the dataset code base.
Well, okay, I'm telling you, that's what that semantic import was supposed to do that. I'm not sure how successful it's been at that.
So semantic import's much broader, though, because it also does things like trying to interpret quantities and entities and so on. I mean, the more basic thing of just being able to infer this is a list of numbers, this is an association of strings to integers, that already exists inside of dataset, and it's much lighter weight and simpler.
Okay, but so look, in terms of naming and structuring and so on, we clearly need the compiler types, the dataset types. These all have to agree.
Well,
and naming and so on.
Stephen, but compiler types are rather different in the sense that dataset type system is very much tied to what dataset does, which is higher level in some ways and more kind of a little bit more abstract.
I don't get this. I don't think that's right. I think that, look, in the end, you're going to want to make C library calls to random low-level data manipulation systems. And it's going to be super useful if the data types that you're putting out from data set just align with the data types in the compiler.
Yeah, but how would you express, well, I know that it's possible to express things in the compiler when you have, for instance, some vector of vectors of things.
Sure.
But the thing is here, it's enough to just say, okay, the container is a sock or the container is a struct. You don't have to say it's struct of what, because it's basically.
Well, Christopher, how would you do that in the compiler?
Wait, so sorry, I don't understand how the data set type doesn't work. So if you have a struct container type, do you not have to specify the types of its elements?
Just expressions.
Yeah, well, you do have to specify, but it's sort of inside. I mean, if you look at the data set type.
So at least, I mean, I'm not sure if this is sort of the issue. I mean, in compiler types, you can definitely have parameterized types. So, you can have a list, or you can, for example, you can have what's effectively a struct type. They're called association tuples in the compiler, where you have a bunch of keys and each key has an associated type with it. If that's what you
maybe it's possible, but I mean, here what's kind of clear and good about this is, at least as it seems to me, is that these namings, they just say essentially what is the container, and there are only 4 types of containers.
Okay, Leonid, this is a simple thing, right? We should make these names agree between the compiler and data sets and data container, by the way. They should all agree, because that way, first, because that's good design, and second of all, because I think it's going to be the case that the backing that you want for both data set and data container is going to want to go to raw C code using, the library loading mechanism that the compiler now has. Am I confused, Christopher? Am I confused about the use of those data types? If these?
Well, I'm not totally sure. I mean, so first of all, I mean, for the design perspective, just it makes the internal code nicer if the names align. That's like, sure, maybe so. Although I'm not sure how hard that refactor is. But in terms of like the practical case of trying to interact with compiled code, I'm not sure how useful it is to have those type systems align. I mean, because if nothing else, it would be very simple to write, some 5-line function that takes a data set type and converts it to a compiled type. I mean, it would just be very easy.
Why not just do that automatically? I mean, why not? Okay.
Maybe a broader question. So, sorry, just a quick question. Is this going to be exposed anywhere? Like, is there a reason why for users we want to make the types align, or is it just for our sort of internal consistency?
Well, I would guess that some form of this schema thing will probably eventually be exposed.
Yeah, that's what I think too.
But the thing is, right now, dataset has its type system, and even if it's used mostly for representational purposes, it's still used throughout the code base. So the thing is, this schema object here, it is very much like intrinsically tied to dataset. So if we start naming these things differently, we will immediately create certain impedance mismatch between dataset type system and the compiler type system. So then if we do it this way, then we should do the complete thing and rewrite dataset type system using the compiler types.
Well, yeah, that's what we should do. I mean,
I'll just mention it's a little more complicated because, for example, the vector type he has here in the compiler, that might be this thing we have, which is called a list vector, which can have any type inside. But for more specific types, it might be, it might be an array type, like a packed array type or a numeric array type. And the compiler distinguishes between those two.
Okay,
but that's exactly the thing, that here it's abstract on a data set level of abstractions,
okay,
which
so
I think is a plus.
Look, here's what we need. We need something which is called something like, data set list vector, or I don't know what the right term is.
Mm-hmm.
Okay, And your 5-line program that you just described, right? That can be the thing that is, for example, the type union specification or something, or type defined in terms of compiler types, that is that type that the data set is dealing with. Does that make sense?
Yeah.
Yeah.
I mean, one thing is I'm not sure. I mean, part of the thing is just that, because it's called the dataset type system, I think there's an urge to make it, align with the other type system we have. But I don't know
if it is even a type system.
Right. I mean,
yeah.
Yes. I mean, it might be sort of a vague schema. I mean, it's either you call it a schema, in which case then, there's no interest in making it align with the compiler type system, because that might really be what it is. And yeah.
All right, let's get off this topic. I think
Okay.
my tentative suggestion would be that you invent some type names that are then written, and you see whether they can be written in terms of compiler types, whether we can have a definition of, in terms of compiler types that gets to those data set types. Perhaps that's silly. I don't know.
Well, one thing, Stephen, to sort of the final thing I wanted to mention here is that I think, given that this schema at the moment is not exposed yet, we can somewhat postpone this decision, but this question, but keep it in mind that we have to.
I don't like it. I think they should be renamed. But anyway, all right, keep going.
Okay. So last time when we had a stream with this approach, I was showing example of the relational database kind of manually imported into Wolfram language using this entity queries and using certain manual schema that I was using to instruct how to do that.
Yep.
Now, since then, I've been working on relational backing. So I moved away from the the original kind of toy example of flat data in memory and moved to properly relational data, to both because it's both important. This is an important thing on its own, but it's also an important use case to illustrate the general approach. The relational model is more complicated for this mapping than the flat model, because the data is spread across several tables which are connected to each other through relational constraints. And so there is a bigger impedance mismatch between these two models.
All right, show us some examples.
Yeah, unfortunately, for the demo, I have to apologize for
the examples are broken.
Well, some of them, but let me show you at least what works, and then for what doesn't, I'll just show what should be there.
Okay, there's a database. Is this generated by us, this picture, or is this just some?
No, and that's it's not the first time you ask. I have to say that we have a function which is somewhere in the experimental functions and databases which I wrote, which does somewhat similar. So we'll make it a priority to expose this and design reviews with you, so that we.
Yeah, I mean, it doesn't look very difficult. And
yeah,
we have graph layout after all. So.
Yeah, exactly, and we can even actually do it better in the sense that we can do lots of these things interactive rather than just the GIF. We can make things collapsible.
Yeah, right, and with graph layout.
Okay. Yeah, exactly. Okay. So, well, this is connecting to database. This, by the way, this is a database which is the one we use for documentation for the database.
Can I see the connection? Because one of the things that I keep on wanting to see happen is all this stuff where we have, I can't even remember it now, entity function and so on. This really isn't right. It's really the wrong way around. It really should be that we have this database object and you keep poking it with things.
Well, in some sense, data set backed by database will become something close to what you have in mind, I think.
Okay, all right, fine.
So that's how this connecting looks right now. Basically, there is a file with this database because it's SQLite. And then you create a relational database object out of it, which is
right.
And you register it as an entity store.
Right. And all of that stuff should go away. I mean, in other words, what you should be doing is just saying, I've got this data set, it is backed by this database, and I don't have to register any entity stores or anything. That stuff is all happening behind the scenes when I do queries with respect to the data set.
Yeah, I think we will probably, it's not going to be very hard to hide it all these steps, so that this will be really as simple as you say. Now, the interesting thing is, I was partly showing this before, but that was on one of the internal meetings, and we didn't have much time to discuss this. So, so basically, now we can generate the schema, which is the similar object to the one I had for the flat data, although it's more complicated, but the structure is similar. From the spec, which effectively shows you from which tables, which fields you want to import, and what should be the structure of the nested data set at the end. And of course, I will immediately mention that this hierarchy definitely is representing partially the natural hierarchy that exists for those tables and how they're connected in the data set. But there is more than one way how you can cut in the database.
I understand. Right. It's a different slices of the
yes,
a bunch of relations. This is essentially some kind of foliation or slice of the set of relations in the database.
Yes, and while the difference here is interesting, because dataset in certain ways is more powerful. Well, how I would put it this way: for certain kind of queries, dataset is better suited than the straightforward entity language, or even like SQL for relational databases, because it automates a number of things. And dataset also allows you to do certain things even lazier than the relational database queries. So by making this cut here and cutting this relational database in a certain way, we are making certain queries harder, but certain other queries we're making easier. And that's the trade-off. So apart from just the general familiarity of dataset users with dataset query language, because hopefully they will not need to learn either SQL or even the entity language to express these queries. But also the queries themselves in some cases will be even shorter. Now, so when we execute this, I hope it's not gonna break. So you get back a similar object, but now it has certain other metadata, which for each layer. So effectively, here is the situation: the data set has now several nested layers, and some of these layers are attached to a database table. For example, here we have the employees database table, but it is spread across two layers. One is a SOC, which represents the collection of records, and the other one inside one is struct, which represents a single record. And so we have, I don't know if you can see the pop-up or not.
Yes.
So the idea is that you can attach to certain layers the symbolic queries. In this case, this is an intermediate representation we use for databases, which is not entity, but which is roughly on a similar level of, it's slightly lower level than entities, but it's much higher level than any other internal representations we have. And so it's an inert internal query, which represents, in this case, this employees table, with the fields renamed in a certain way. And now, if you expand certain internals, you can see that other tables like payments and orders, they also have a similar structure. I don't know.
So can I summarize? I mean, basically, you're saying, given this schema, and this schema is somewhat similar to what we expect the data container schema to look like. Given this schema, you have some mapping that tells you for every element of the schema, how would you actually get the data associated with that element from the underlying database?
Yes, but the crucial part here is that you connect not necessarily a single field to a database, but you connect a level of a data set.
I understand.
To
I understand. So you have an optimized way of getting this. But I mean, in the end, some particular element in your schema, you say, I want to get the, customer, whatever, payment history or something. In the end, customer payment history is obtained as the following SQL query. I mean, that's in the end, that's what's going to happen underneath.
Yes. And in fact, this is what's going to happen right here down below in this demo. So here is the I have a function. Well, obviously it's now still, it will all be hidden by a certain interface. Now it's some separate functions, but this shows how the full data extraction query for this schema looks like, and it's a pretty big symbolic expression.
Yep.
Now, when we when we extract the data, then what's happening? Well, it's taking some time, but hopefully it will still work in the end. It was working for me before. So this is supposed to generate the full SQL necessary for extract full data from these data sets.
I understand. And then it's going to return a subdata set.
Yeah, and so in this case, it returned this this data set. And if actually I didn't try it, but if I try, for example, I have some kind of a part extraction functionality. So we should probably be able to just do. So if it's just, for example, customers, and then still, let's say we only want.
What the heck is that down thing doing?
Well, it's I didn't know how to explain or how to express that. I want to go down to the inner layer without
as
actually.
Opposed to what?
Isn't it the same as all?
Well, all is not exactly the same, because all will keep the outer layer, and I want to strip it. Like,
by strip, you mean flatten, basically.
Well, yes. Well, anyway, I'm not probably. I just wanted to show that although I didn't try this before.
But wait a second. Alliness is a feature of the actual data. What you're manipulating is the skeleton, the schema.
Yes.
So alliness is different. In other words, all is just like a node on this, in some graph. It's just like there's nothing there. There's no, and you happen to be. You could simply canonicalize your schema that whenever you have something where it's don't do anything here, it removes that from the schema. So you have a non-canonical form of the schema in which you say, well, this level, what do I say about this level? Oh, just use all of that level. Okay, you can simplify the schema by removing that, but you don't have to think about it conceptually as a different thing.
Yes, but what you are describing is more like a slice, or slice is internal, but part operation effectively acting on data set. While here, but you're right. This is more just to see the inner layers of the schema, just how they look.
Right. This is operating on the skeleton.
Yeah, this is operating on the skeleton.
Right, and that the operations on the skeleton will be relevant for data container as well.
Yeah, I guess so.
Right. So for example, you do operations on the skeleton, And the whole point is, as you change the skeleton, the animal altogether moves, so to speak. That is, if you say, I want to rearrange the skeleton in this way, then you can, you can apply that change, that transformation of the skeleton to the actual data.
In fact, this is exactly what is happening for when I'm the process of dataset query compilation in this approach is exactly the process of manipulating this skeleton or this schema.
Yes, right.
And from that, we generate the final data transformation that is supposed to operate on underlying data. That's the idea. It's exactly that. I was just trying to see whether we can. Yeah, well, that's probably not meant to. Anyway, it doesn't matter. So the thing is, whenever you have this schema, there are ways to extract the data at the end. And then I don't show it here, but it's still it's going to be again behind the dataset interface. But the user will see the unflattened dataset back. So the user will not obviously see this huge flat data. They'll see the what they are used to see.
I get it.
For the so well, here is where things are not good currently. I was going to show certain certain compilation of certain queries. One was rather simple, was the slice, which is extracting certain parts of the schema, and it was supposed to add.
Okay, fine. But what is slice?
Slice is the version of part used internally for dataset, and the reason it was introduced mainly was to take care of the missings, and also to not bark on things which go out of range. Because basically, for the purposes of dataset, part operation was a little bit too rigid in how it reacted. It was complaining for going out of range and for certain things where we would instead maybe want missings.
I understand. I mean, that's kind of a subtle thing which we need to deal with. I mean, that's part of the whole calculus of missing is a part that, I mean, just like with lookup, for example, in dataset, you go to failure objects rather than in, yeah, that's tricky.
Exactly. And also the other thing which is good about slice is that it is an operator. So it's very declarative. It can be, actually this was, in general, this was one of the internal design principles of dataset, that the query that dataset generates is pretty declarative. So, and this is important here in this context, because what I'm taking as a source is not the query as written here, but the query as, well, here maybe, but in general, it will be the query that dataset spits out when it compiles the original user's query into its internal form.
Yeah, okay,
and that's
fine.
what, yeah. And so here is, for example, this, here's the query that, one of the queries that the user might write, which is they are selecting certain employees on one level, then they pick customers, and for the customers, they select all customers who come from France.
I get it.
But the actual query that is generated from dataset is different. You can see it looks more like this. So it compiles this original query into things involving right composition, slices, and some selects are mapped.
Can we zoom out for a second? Big picture here.
Sure.
Okay. What we're trying to do is, you've got a database. It's got some schema. You want to define a slice through that schema that you want to map into a data set. First point, right?
Yes.
Okay. So we've got some function that takes, in this case, I mean, what we want to do is to back data sets with all kinds of stuff, with files, with, relational databases, with,
yes.
whatever. Okay. So what you have is a converter that goes from the relational database, which sings and dances and has tentacles all over the place. And you want to take the particular slice that you are going to kind of the freeze-dried slice that you are going to be examining in your data set.
Exactly.
Correct?
Yes.
Okay. So first function we need is the thing that maps from the original schemas, and that's the thing you were showing a couple of slides ago, from the original schemas to essentially the data set schema.
Mm-hmm.
And so that's first thing. So second thing is, once you've defined that mapping and you've created your data set, extracted from the relational database, then all of the queries that are your sort of traditional queries that run in a data set, you, by extreme cleverness, are going to compile all those queries into SQL, basically, in the end, and
Yes.
run them. Is that correct?
Exactly. Absolutely.
Okay. All right. Fine. So the details of how you do that, while interesting, are probably not what we should be mostly concentrating on, because the primary thing we want to understand is what is the user level functional design of what's happening here. And,
yes. Yes. So I totally agree with everything you said. I think that the internals that you mentioned, while generally I agree they are not very interesting for the end user, but in terms of our internal design, they might be quite interesting because they teach us a lot about what's happening when the data model that we are connecting to is more complex than just a single file or a single flat list of things. Because, for instance, here, well, unfortunately, because of these things are half broken, I can't show it right now. But one of the subtleties which are very hard to overcome here is that essentially you can think of this backing as if each layer of data set in general points to a different data source in some sense.
Okay.
And those data sources are somehow connected. So in this case, a different data source is a table. But in other cases, I can imagine that, for example, you can have a nested data set which is combined from several arrow data sets or several flat lists of flat files or whatnot. And then they will be attached to different levels of a data set. And somehow they will be connected, just like here. So my point is, this model is interesting not just because it's internals of how we connect and manage to generate SQL, but also because in general, I think this will be a pretty common situation that different layers of this data set, different levels.
I understand. Yeah, right. I mean, what's happening is we've got this whole octopus, which is the relational database. And this is not a great image. We're taking slices of the octopus, so to speak, which are and they're different slices that are being taken that correspond to different levels in the data set.
Yes, but it's
the same octopus underneath.
Yes, but it's in terms of the if you look from this sort of a high level, then yes. If you look at how it works internally, again, I agree, it's probably not very interesting for the user, but it's pretty interesting that, for example, when you take a single record out of certain table, your SOC level disappears, and then if you only have a struct, or if you take a single field of a struct, then your struct level disappears, and you only have a SOC where that level becomes essentially what primary key points to. So the thing is, the relationship between levels and data sources is rather fluid.
Yeah, I understand. Okay, we're going to run out of time here, and so can we just see the rest of this presentation?
It's pretty much it. Or the only thing I wanted to say.
Slide 8 of 13, so there has to be some other stuff.
Oh yeah, that's mostly the additional material. There was this slide with similarities and differences was the data container, but it's mostly borrowed from the old presentation I had. So I guess Christopher summarized this nicely, that a data container is more currently more targeted towards more rectangular things, and also data container necessarily, well, at least it is, I think it's more intended for things which live in the kernel or somehow close to the kernel, while the approach that I am pursuing,
I don't think so. Why are we saying that? I mean, I don't think.
Well, maybe okay, let me put it this way. You probably can, through data container, connect to some external data sources like relational database or whatnot. But I thought that the at least the original idea of data container was to provide more kind of efficient engine within the kernel that allows you to do things.
Let's zoom out for a second, okay? Okay, first point is, at the level of expressions, we have a very flexible way of representing data. Hierarchical, not the same in all directions, et cetera, et cetera, et cetera, et cetera, et cetera. Okay? We also have, but we also believe that the underlying schema, the internal schema, we will often want simple internal schemas. They might be slices of databases. They might be some kind of, thing in an arrow or whatever else. But then we've got this translation from the external, extremely flexible expression to that internal form. And sometimes that translation is of tabular data. Sometimes we can imagine that the tabular data has little pockets of deeper stuff, of hierarchical stuff, right? But what you're showing is you can flatten the hierarchical stuff out. Rob has not done that for data container, but we could do that for data container. We could have a schema in data container that doesn't just say this is in these units, et cetera, et cetera, et cetera, but rather says, oh, and this part is hierarchical.
Yeah, I guess the main point I was trying to make is that the technology I'm developing is mostly about translation. And it doesn't care.
As opposed to what?
As opposed to certain internals of, for example, providing efficient engine with efficient compiler-based column types, or some internal efficient selects or other primitives. So to me, those things will be, I'll be kind of a client of those things. So if they're provided, then if all I need to have this thing working is a set of primitives exposed to me so that I know how to make this translation working.
I know. I mean, because in the end, there's an API, I mean, like for dataset. Well, dataset in the end can fall back to standard symbolic evaluation, can it not, for doing queries?
Yeah.
Right?
Sure.
And presumably you should be able to do the same thing, even though, you'd like to be able to do it at the SQL level. If the thing is asking you to compute a mayor G function of something, you're going to have to pull it back out to the expression level.
Sure. But that's right now, that's kind of a one way thing, because then like once you convert back, you kind of leave the convenience of working within the backend. But in the future, we might even be able to run certain things kind of in a callback style from the backend, but that's kind of further away.
Right. Okay.
Yeah.
I'll just. Yeah. I just thought I'd mention, if we try and make the data container idea, the rectangularish idea, do too much, then I think we lose some of the potential efficiencies, or it's very hard to keep the efficiencies if we try and do too much at once.
Yeah, I agree. So we're not concentrating on that right now. We're going to deal with rectangular stuff. And in data container, we're dealing with rectangular stuff. In what Leonid is doing, I think we've defined what we're talking about. The only thing which I think is useful is, okay, so we have the function dimensions. Dimensions will take, as we all know, a list of lists that are rectangularized, and it'll give us a characterization of those levels. What Leonid was showing earlier, we could view as being something like dimensions, but applicable to nested associations, if I'm not mistaken.
Steven, with one addition, which is, in my approach, the mapping to generated field names is pretty crucial.
No, I'm sorry, I don't understand. If you've got a data set, which is a nested collection of associations, okay? One question is, what is its schema? Okay, its schema, as in the thing you were showing, which is a nested, which is not the full you know, let's see, okay. The whole point is you've got all the data there, and you've got this association with a key name going to this thing, and assume that you have this rectangularized version where all the columns have the same keys in them. What you had there was a summary of what the key structure is, right?
Yeah, but the thing is, when I take a data set and I generate what I call schema from it, one of the steps is to invent this unique field names.
Okay, but that's an internal implementation detail. That's not what I'm talking about. What I'm talking about is you've got to be able to have some way of specifying that, in other words, you've got a collection of nested associations, which are rectangular in the sense that all the columns of a given thing have the same structure. You understand what I'm saying?
Yes, but this statement and this structure is already expressed by dataset type.
So I know, I understand that. I'm saying go back to further back in your presentation. You had a thing.
Let me see.
Yeah, maybe it was that one. I'm not sure. Scroll down. You had a thing where you were showing as an expression the skeleton, the schema of how those keys were connected.
Yeah, it's
where is it?
I'll find it. I think it's in expanded.
No, you had it in a top level thing. It was an output line, a top level output line. It showed what the schema looks like. Okay, it's that right hand side thing there, more or less, but it just says moon's arrow. I mean, we could generate it by hand.
Yeah, you mean this, right?
No, I don't mean that. I mean you had a thing which was a pure expression, top level expression that just said, where was it? I think it was in connection with the other data set, in connection with the
okay, that's what you mean in the relational one, right?
Yes.
Yeah, it's in the demo, this one.
Yes, that one there. That's the one I'm talking about.
Yeah, okay.
Okay, so that is a symbolic representation, a simple symbolic representation of the schema, correct?
Oh, yes. Yeah, I guess so. It just
yes. So any rectangularized collection of nested associations has a skeleton like this.
Yeah, I would say it's not the most general one because it was for relational database, I left alone two other components of dataset which are vectors and tuples.
I know that. Just like when you give a part specification, you have to have this notion of key that represents whether it is an association key or whether it is a part number in the traditional positional part representation, right? So similarly here, there are levels in here which should say, instead of customer's arrow, whatever, there's a level there that is something that represents a positionally specified list, as opposed to here, where the elements are all tuple-like elements that are, specific keys in an association.
Yeah, and I'll just mention, Stephen, that's what I tried to address with this data dimensions command I put together, that deciphers the keys, and it uses key list for an association level, and it just uses a number at this stage. I mean, we can think of all sorts of different designs.
Okay, so you've already got
what it does.
Okay.
Yeah, fine. I've already got that. Yeah, for rectangular data.
I understand, but that's what Leonid has. He has rectangular data too. That's what he gets from a relational database.
Yeah. Yeah, but if we look at this spec certainly shows you the relationship between things, but the full schema that I'm generating is obviously.
I know it's much more detailed. Okay.
Yeah.
But this is what you need. You could reconstruct. Okay. I just think this is a useful representation, which any data set, you can turn it into this kind of representation along with the things that represent ordinary lists.
Mm-hmm.
And, that's a thing which, as Rob has said, is a commonality between this and data container.
Mm-hmm. Yeah. So do you
I-
suggest some modified form of this to be something that we somehow expose or use?
Yes.
Yeah.
Yes. Simple as that. Yes.
Okay.
And the fact that under the hood, you're doing much more elaborate, complicated things representing how this corresponds to SQL and so on, that's magnificent, but it's a different thing.
Yeah, sure. I mean, that was exactly the idea why I came up with this short representation, because obviously,
right. So I'm just saying, expose that. Listen,
yeah.
I have to go in about 1 minute here. We had a couple of comments on our live stream, particularly about NetTrain interacting with dataset, which I don't know how much we've done on. I mean, can you feed? You can feed a dataset to the machine learning functions, can't you?
Yes.
Should be possible. Yeah.
Yes, I think that the syntax right now for machine learning is slightly different than NetTrain, simply because machine learning, you can feed a data set similar to a matrix, and you can use arrow column. So you can say data set of ABC, and then train on like to predict C, for example, or to classify C. In NetTrain is a bit different because we have this port syntax. So we have. I also something that I noticed that the syntax is slightly unaligned, but I think you can use the dataset. I use it recently.
Okay.
I can double check, but yes.
Okay. Listen, I have to run. This was good, and great direction, and I think we know where we're going with this. And I'm afraid we were just trying to squeeze this in right before the beginning of the summer school, which begins at about 20 minutes or something. So I
okay.
have to go.
Good luck.
Okay.